Hello again to the Siemens KNX Basic Course Chapter 2. It will give you a general overview of the building automation system KNX and provide you with system arguments in favor of it. First, we have to realize the possible fields of electrical applications in modern buildings. It is also still very often discussed if a bus system is really required, whatever it may be. In this regard, the cost factor plays an important role, but we will talk about this later. The presented applications can be grouped to goals which are in parts mandatory or which the user would like to achieve for personal reasons. For one, it includes safety and security. Security refers to protection against unauthorized access, represented by monitoring technologies. Building safety also includes the alarming and protection against the threat of technical damage caused by environmental impacts. This can be the monitoring of physical environmental conditions, for example, temperature, wind speed, humidity and precipitation, as provided by a weather central. Based on these data, shading systems can be controlled. The second goal is the optimal use of energy. This includes the minimization of energy consumption. This requirement is nowadays ruled by law. In order to achieve the legally defined targets for energy saving, it is necessary to use a building automation system. The question is only which one is suitable best. KNX offers the most extensive system options from more than 400 manufacturers. The application fields of optimized energy efficiency are energy management, HVAC, metering and lighting control. In the private sector, there are also the white appliances. The vision to operate white appliances only if free renewable energy, for example from solar panels, is available, is expressed by many suppliers of suitable equipment. The third goal, which requires a communicative building automation, is user comfort. In order to control a building and its functions from all places, a bus system is indispensable. A single remote control for all possible functions is the dream of all users with uncountable numbers of individual remote controls on their living room tables. This includes also the disciplines entertainment electronics and media technology. Let's look at a few application examples now. Example 1. Central functions. Centrally controlled functions serve mainly for the enhancement of comfort. A single control command can be used to turn all consumers or specific group of consumers on and off simultaneously. Another advantage of the centrally controlled functions is to avoid dangerous situations. These situations can arise when the users forget to turn off their lighting, heaters, stove and flat irons when leaving the building. In addition, other functions can be activated, such as the alarm system and the blinds automatic control. Example 2. Scene and light level control. A scene is in principle like a central function. Accordingly, the transitions to the real central function are fluent. In a scene, however, functions of different disciplines are controlled with varying values. A classical central function controls functions of the same type, for example the entire light, on or off. And also in contrast to the central command, the end user may have the option to change the scenes at any time himself. Example 3. Light control. KNX lighting control exists already for more than 25 years. Empirical studies have shown that only constant light control can already save up to 50% of the electricity costs for lighting. In comparison to air conditioning, In particular heating, the savings potential is lower, but not unimportant. That is because of the expenses for electrical energy. They are always much higher than the costs for gas, district heating and heating oil as per kilowatt-hour. Especially in summer, an energy saving of up to 75% is possible because of the heat dissipation of active lights. It must normally be neutralized by the air condition, causing even more electricity consumption. The use of intelligent blinds instead, using the natural light, can help to avoid running the air condition and thus contributing to a higher energy efficiency level of the building. Example 4. Central monitoring and operation. In an intelligent building, there are many operating conditions that you want to monitor. Visualizations show these data clearly and at one place. They are available in a variety of designs, from small monochromatic displays for status displays in one room to the web server-based system which can be used with any browser at any place. Nowadays, the operating functions are integrated into the same visualization. This enables a complete, central and comfortable system control. Important hint: for a KNX system, such central tools and interfaces are principally optional. The main functions are carried out independently by the sensors and actuators in the system. Example 5. Remote monitoring, operation and maintenance service. More than 20 years ago, the first devices for remote access to an EIB plant appeared on the market. They were modem couplers, enabling the user to dial a phone number with an extension to inquire certain plant states and also control some of the functions. These devices naturally have been upgraded eventually, so that they have turned to be the modern web server-based network solutions I have mentioned in the previous example. This of course includes remote monitoring and control by means of a smartphone. Beside this, the presently available components for remote access offer the option of remote diagnostics and in many cases also repair, if the fault was caused just by a misconfigured device. This in turn saves time and maintenance costs for the customer. Example 6. Partition wall control. You can't imagine what partition wall control really means. Admittedly, it is somehow misleading. It's not the wall which is controlled, but the room functions. They depend on the position of flexible walls, in or out. The basic requirement is that several smaller, identical rooms shall be combined to bigger rooms, or even all of them to one large room by removing the partition walls. When this happens, all controls shall be paralleled, and that shall happen automatically, without the need of any manual reconfiguration by computer or even rewiring. This is possible with KNX and special controllers because of the strict separation between sensor and actuator functions. Example 7. Panic function. Everyone is familiar with the red button which allegedly each bank employee has under his desk. If this is true or not, in any case, its function is often required. The function is to report a hazardous situation, often that of a burglary, with a simple push of a button to the outside world. Is this panic switch installed in a residential home? It can in addition also trigger a panic scene. All lights in the house on and all shutters and blinds up. You also could switch on a stroboscopic lamp and an alarm siren by this scene. It is actually a special form of the scene. There is a certain sequence of preset commands that cannot be changed by the user. This is then called an event program. Another example of such an event program is the application in the kids' room. If small children wake up at night, then they tend to panic due to the darkness. An illuminated switch provides a good solution here. If the kid taps it, the lighting is dimmed up, but not to the maximum. In addition, the parents in the bedroom could receive an audio-visual notification on a display. Example 8. Air condition and temperature control. After all the presented examples, it should no longer appear surprising to mention that the KNX bus obviously also offers a considerable energy-saving potential in the climate and temperature control. For one, there is the exact temperature regulation to tenths of a degree, which can be planned per each room individually. Then the period-compliant setpoint adjustment via a central timer and the occupation-dependent, also automatic, temperature setpoint control. In addition, by monitoring of windows, it is avoided to continue with the normal setpoint when the windows are open. It is instead turned to building protection mode. This is either 7 or 35 degrees Celsius, so that you both save energy and avoid building damage by frost or overheating. By the use of the so-called primary to secondary circuit coupling, it is finally achieved that the central energy producers for heating and chilling are controlled by demand. This technique allows the direct management of the flow temperatures independence on the requested energy from the individual rooms. Example 9. Present simulation. During the absence of the building owner, the building still is operated as if it would be inhabited. This means that the lighting and shading functions visible from the outside are intelligently simulated during the owner's absence. The present simulation records the user's controls over several weeks. Then it plays them back weekday and time matching with an adjustable variance. So for unwelcome observers, it will become much more difficult to judge whether there is really no one at home. So the house is well protected also without an expensive alarm system. Example 10. Optimization of energy consumption. KNX can make an important contribution to smart grid. For a long time, KNX actuators exist whose power and energy consumption can be accurately recorded. There are also KNX electricity meters to monitor the total electricity energy consumption easily. By maximum monitoring and automatic consumer shutdown, where it is possible and makes sense, the load curves of buildings are stabilized and energy is mainly consumed when the price for it is low. In connection with the use of renewable energy sources, that means specifically the power consumption of specific electrical devices is controlled, for example, by the availability of solar power. A household appliance, such as a washing machine, dryer or dishwasher, is no longer operated at night, but only when the sun is shining. Selling to customers' demands. Using the application examples described so far, a potential customer can already very clearly be explained the benefits of a KNX system. Many customers are technically inexperienced, therefore it makes not much sense to tell them something about KNX. Instead, we must explain the application possibilities and their use precisely. It is always important to know exactly what a customer expects of an intelligent house control system. Energy and cost savings, more security, or a higher convenience, or just all together? In any case, the cost aspect should be mentioned only at the very end of the system's features presentation. Then you have won the customer already for the system, so that he only asks if certain features can be realized at a lower price. In this situation, you can offer workarounds, for example actuators with many channels, or redesign of functions, for example switching instead of dimming, electrical thermal drives instead of motorized valve drives for temperature control. Summary: Advantages of KNX. Increased safety. Economic use of energy during the operation of buildings. Simple adaptation of the electrical installation to the changing requirements of the user. Higher degree of convenience. Future-proof installations. Wide range of available off-the-shelf components from many manufacturers. Large service network of qualified contractors, planners and integrators. The above-mentioned arguments are weighed differently depending on the also differing expectations of system integrators and end users. They are more or less important. For example, if you take commercial and residential buildings, disabled or normal, young or elderly people, etc. You have to take this always into consideration when marketing this technology. Disadvantages of classic installation. This image shall clarify the problems inherent in conventional solutions. For all disciplines you will find individual solutions, for example a blind control system of a manufacturer of shading technology, a heating control system from a manufacturer of heaters, and something for the lighting automation from lighting manufacturers. But if you try to synchronize all disciplines into one single management system, as it is sensible nowadays, you won't succeed easily with such individual solutions. If you have to do it nevertheless, it will become complicated, complex and expensive.
Advantages of a KNX installation. A KNX plant integrates all disciplines in a unified way, so as to speak under one roof. Therefore, synergies can be used. And the more functionality is required, the more affordable the system will be, compared to traditional standalone solutions. And because of the unique system planning and design software ETS, despite of its high complexity, it remains simple and reviewable. Beside this, the system is highly flexible and can be modified and expanded later to match the changed needs of the user. We have demonstrated this quite successfully during the last 25 years. Objectives and tasks of the KNX Association. When the KNX Association has been founded, it had only 8 members. This number has increased to over 420 by the end of 2017, including companies who had never been a member of the legacy associations IBA, Batibus and EHSA. These companies represent over 80% of the European market for electrical installation goods and household appliances. Many new members of KNX now come from other continents. Both R&D and manufacturing enterprises may apply for membership, and also service providers, energy suppliers, etc. On the KNX homepage, knx.org, you can always open the current list of them. Among others, the KNX Association consults its members in developing new KNX products as regarding certification regulations. It drives national and international standardization activities. It certifies and surveys KNX training centers to guarantee a worldwide unique education level. It promotes KNX on national and international fairs, on the internet and by print media such as the KNX Journal. It supports research at universities by the so-called Scientific Partnership Program. Some information about the former associations which have been merged to found the KNX Association. The Batibus Club in France has been turned into the KNX National of France. KNX Association continues the software business inherited from EIBA, selling ETS and its apps. KNX Association is also responsible for the permanent redesign and updating of ETS. KNX Association also still continues the certification of products in compliance with the former EIB, since the twisted pair focused KNX products are still backwards compatible to EIB. EHSA and Partibus in country have been completely discontinued and their activities been closed. Now we start with the technical introduction. Basic requirement for an intelligent building control is the splitting of two tasks. A. The task of controlling certain functions. You might also call it the command transmission. B. The task execution of these functions, or the command reception. If you look at the standard light switch, it is not compliant with the above stated requirements. It is both command transmitter and receiver in one part, so the load which is controlled by the switch can't be controlled by another command unit independently. Therefore, any form of remote control is excluded already from the start. In a bus system like KNX, these tasks are strictly separated, as you can see on the graphic. In the upper part, you see the command receivers, in experts' language also called actuators, for example, for lighting, heating and blinds control. In the lower part, you can find the command transmitters, also called sensors. As you can see, there can be various types of sensors to control the actuators. The only requirement here is the control of any actuator by a certain sensor must be sensible. And basically each sensor can control the same actuator, as well as one sensor can control many actuators simultaneously. If many sensors control the same actuator, this happens one by one, as the KNX is a serial bus. It is quite strictly organized, like in a military organization, which also means the latest order is the valid one, extinguishing all previous commands to the same control instance. In this way, all functions in a plant can be operated from everywhere at any time. We have reached the highest degree of flexibility and freedom of usage.
Usable communication media. At its origin, the KNX bus was developed as a two-wire bus. The information is transmitted by means of a pair of wires in a suitable cable. Due to the very special signal shape, only a specific type of cable can be used. This cable conveys the KNX signal exclusively, nothing else. This is called a separate control line. This form of installation is mainly used in new buildings and for total refurbishments. More information on this later. The second medium has been power line. That means the 230-volt mains line used for energy supplies of the electrical loads in a building. It was launched back in 1997. The bus signal is converted and superimposed on the 50 Hz voltage by frequency modulation, using a suitable frequency band. This method saves wiring, but does not only have advantages. As high-frequency signals are used, they can spread on the mains everywhere. However, it must be avoided to send them to the neighborhood, as they may cause interference there by using filter chokes. The third option of data transmission was invented in 2002 with radio signaling. Since then, KNX can also be operated wirelessly, which makes it suitable also for the conversion of old into smart buildings. At the same year, also the Ethernet adaptation has been launched. From this time onwards, it is possible to link up KNX to the Internet. So even far distant premises can be connected now to a unified communication network. The transmission medium twisted pair, two-wire control line. All bus subscribers, sensors, actuators and controllers are paralleled and so always linked to each other on the shortest way. If the energy line, 230-volt mains, is also looped through from load to load parallel to the bus wire, the complete wiring effort can be reduced by up to 60%. So also way more functions can be realized than in standard electrical installations. Beside this, transparency and simplicity of the installation are improved. In most cases, the bus line also powers the subscribers with the required control energy. Central control units are principally possible, but not mandatory, since all KNX subscribers have their own intelligence. KNX is a fully decentralized system in which sensors control the actuators always in the direct way, driven by events. KNX System Overview. KNX supports different methods of designing and commissioning, depending on the complexity of the planned installation. In any case, always the standard KNX protocol is used. That is a worldwide standardized set of commands when the bus devices are commissioned. For the regular communication, also universally standardized data point types are used. Depending on the selected project design method and the medium of the bus devices, extensions to the protocol are added. It is called system mode if the complete assembly is designed and commissioned by means of ETS. The easy mode combines several commissioning methods which make the use of a PC-based tool dispensable and offer faster commissioning. But an easy mode also means that this kind of solution remains on a simple level, providing not the high number of functions and the high flexibility as offered by the system mode. The easy mode also distinguishes three different ways of commissioning. 1. The controller mode. A central device which knows the program configuration of all line subscribers analyzes the bus installation after it has been completely installed and powered. The commissioning person only has to assign the recognized sensor functions to the matching actuator channels. The rest is done by the controller. Usually, the controller can be removed after the commissioning job. 2. The push-button mode. This mode doesn't require any additional tool. The sensor and actuator channels can be paired simply by operating learning buttons or slide switches. So, fully working installations can be erected in very short time. Bear in mind also here, not all possible settings are available, especially parameters can't be changed. 3. LTE mode. LTE stands for Logical Tag Extended. It is also a kind of controller mode. However, the structure of the functional addresses, the so-called zones, is pre-designed. The subscribers having a display can be directly and independently assigned to their zones. Others require a commissioning controller with a display to assign the zones. LTE mode devices can be parameterized, but only by use of a computer tool. Devices with a different commissioning mode cannot communicate directly with one another, but suitable gateways to link such devices anyway are usually available. KNX interworking. KNX interworking describes a standardized communication model which guarantees that all field devices for the KNX are 100% compatible with each other, no matter which brand they are. This model is split into 6 layers. The lowest layer deals with the data transmitting media, also called the physical layer. Here the cables and wires are specified, the data rates and their modulation on the medium. Layer 2. To exchange data within a medium, the so-called bus coupling units, short BCUs, are required. The operating systems of these BCUs must be KNX certified to ensure compatibility with the protocol stack. The BCU stacks are designed in conformity with International Standard for Serial Communication ISO 7498 as of 1979, also very often called the 7-layer model of serial data exchange. It has been unchanged since then, which underlines its universal importance for all kinds of digital communication of the present. BCUs are the binding between the application module on layer 3 and the bus medium, layer 1. The application modules provide standardized interfaces to connect to the BCUs. The meaning of this is explained in detail in the chapter Bus Devices. Nowadays, however, BCUs and application modules are integrated into one another to form so-called monoblock devices. To make these devices work according to the customer's demands, an application software is necessary. See layer 4 in the image. Depending on the commissioning mode, the application software can be fully pre-installed in easy mode or available separately for download from the manufacturer's support websites, or more and more also on the central download server of KNX Association. In case of system mode applications, their design is also standardized, so that it can be used in ETS to configure and commission the bus devices of the different brands in one project. See layer 5. At the top of the pyramid, we find the different standardized functions, which only can be made working because they are based on the 5 layers below. Summary of the previously presented facts and arguments in favor of KNX. 1. Devices of different manufacturers and functions bearing the KNX trademark and serving the same ways of commissioning can be linked to a working system without problems. It is already planned that future versions of ETS also permit to link no S-mode devices. KNX installation can be maintained without problems by each skilled KNX contractor, for there is only one unique engineering and commissioning tool running on regular Windows PCs, the ETS engineering tool software. 3. This tool does not require programmers' skills. 4. Each contractor being trained according to the KNX guidelines is permitted to use the KNX logo for his advertising and is registered in a file of the skilled technicians with the KNX organization. As already stated in the chapter General Information, ETS is the only comprehensively usable tool for all KNX plans, beginning with project design until maintenance and repair in later states of the building operations. The current ETS version is 5.6.4 as of June 2018 and is available in 4 different editions. 1. Demo version can be downloaded for free after registration in the my.knx online portal. It is about 120 MB large. This is actually the full version, however, it is limited to only 5 bus devices in one project, cannot operate any apps or plugins, and cannot be updated since it is not licensed. 2. Light version. After application of a light license key dongle, ETS 5 will be fully operational as regarding apps and plugins. It still has a limitation to maximum 20 devices per project. 3. Professional version. This is actually the unlimited software package. When the corresponding license is branded on the dongle, you might already have from the light version or a new one. Also, the limit to the number of bus devices is removed. It also supports any additionally purchased apps. As regarding the apps, a trick can be used here. App license keys can be branded on a separate dongle. ETS recognizes all plugged-in dongles and so all licenses on them simultaneously. The apps can be installed on every PC, but work only if the app dongle is plugged in. 4. Supplementary version. All Pro licenses can have 2 supplementary licenses. They are also professional unlimited versions. However, they can be purchased only in a bundle together with a Pro version, not separately later. The purpose is to save money if more than one license is required. The regular price as of June 2018 is 1,300 euros instead of 3,000 euros, VAT excluded, for 3 regular Pro versions. Handling of the dongle keys. ETS checks cyclically if ETS5 dongles are plugged into a USB port of the PC. If this is true, the corresponding licenses are activated in ETS. The user must transfer the licenses purchased from KNX Association to the dongle via the assignment tool in ETS. A dongle can be branded with multiple licenses, which is required especially for the apps. As already mentioned above, ETS can recognize several dongles and thus combine their licenses. Thank you for listening. You have reached the end of Chapter 2, System Arguments.